Hey there, this is Professor Janacek. I want to go over some operations for vectors. Here at the top of the page, we've got some definitions for adding vectors and for subtracting vectors, and also for multiplying a scalar times a vector. We call that scalar multiplication. Now, the definitions are pretty straightforward, easy to follow, I hope. I want to talk about some concepts for these operations. For vector addition, we can think of it geometrically. So suppose we have vector u and vector v. Notice I am using the vector notation there rather than bold-facing those vectors. There are two methods for imagining how to add these vectors. Let's talk about the triangle method. For this method, I'm going to take vector u and then vector v, and I'm going to align them, from head to tail. And then all I have to do is go from the tail of one to the head of the other, and that's my resultant vector. That's what you get if you add vectors u and v. There's another method called the parallelogram method. This time I'm going to take vector u and vector v, and I'm going to instead put them tail to tail. And now what I'm going to do is I'm going to create a parallelogram using a second copy of each one of these. So now I've created a parallelogram, and I'm going to go from where they both start to where they both end. And that's my resultant vector. So you'll notice no matter which technique you use, the triangle method or the parallelogram method, you get the same result. When it comes to vector subtraction, I think a nice way of thinking of this, instead of subtracting them, you could think of adding the opposite. And so you could take a -1 multiplied by vector v and then add that to vector u. That's sometimes a little easier than doing the subtraction, just so you don't lose those negatives in there. And here at the bottom of the page, I have a whole list of properties. You can look over those. Enjoy!